Okay guys, let's get going. So, once upon a time, we graphed...
No, not coming again.
We change that. We graphed something like this. Does anybody remember what the graph of y equals absolute value of x looked like? What shape did it take? You guys remember?
Origin. Oh wait.
No, it wasn't a line. Shh, hey, enough talking. Alright, it was not a line, no. When you plug in negative values to an absolute value, it comes out positive, right? When you plug in positives, it stays positive. And if we graph those points, it looks like this. This was way back in like chapter 3 or something. Made a V. Made a V. Okay, now what happens to the graph if I put a +2 next to the x?
It moves to.
Right to, or left to.
Okay, yeah. So what ended up happening is it affects the x motion. Remember, this is the x-axis, right?
Motion.
Yes. X moves it right or left. Okay, the y value moves it up or down. So if you put a number directly on the x, it affects the left right, but it does kind of the opposite of what you might guess. +2 actually moved it left 2. Okay, so normally we think of +2 on the x right here, right? But if you add a 2, everything happens 2 faster, basically. So everything's over here on left 2. Okay, what is this -3 going to do to the graph?
Moves it 3 down.
Moves it down 3. Yeah, that one was a little more obvious. The one that's not on the x. Yeah, so though that's kind of the pattern, but we're not really graphing this today. But these tricks work not just with absolute value; it works with pretty much any graph that you do. So what we're going to be talking about today is the graph of y equals x squared and a little bit even a y equals x cubed. So doing some exponential stuff here. Have we seen this graph before, y equals x squared? Okay, this will be a first then.
Oh, weird.
Huh?
Will we find the parabola before?
I don't know. Oh yeah, we did graph a couple of these. Yeah, you're right. I remember now. Okay. So what's going to happen is we're going to plug in for, well, this is just one section. We're going to plug in some values for x and then see what pops out. If I plug in -2 for x, what's going to come out?
34. Unless it has parentheses, which would be just...
Okay, when the square's on the x though, you have to square all of x, so it's like parentheses. So we're squaring all of -2, so it would be +4. -2 times -2 is +4. When I square -1, 0 squared, 1 squared, 2 squared. There's some symmetry here. 4, 1, 0, 1, 4. Okay, when I go to graph these, it looks like this. You guys remember this shape? We did a couple of them once upon a time. Hey. Alright, this shape is called a parabola. Anytime you graph an x squared, it turns into a parabola. So it's kind of like exponential growth going both directions. Alright, what do you think is going to happen to the parabola if I do like an x minus 1 in the parentheses squared? What do you think that's going to do to the parabola?
It's going to go to one to the right. 2 to the right. No.
Atticus, my patience is about right here, right now. I'm grumpy today. I didn't get much sleep. You're going to push me over. Okay. Yeah, it's going to move 1 to the right. It's the same rules as this. If it's directly on the x, it affects the x motion. So this just moves the graph 1 to the right, and this would move it, guess what? 2 up. So the parabola would move 1 to the right and 2 up. Do you guys know what this point on the parabola is called at the bottom?
It's just.
It's called the vertex.
I knew that.
We also called it that on the absolute value function. The bottom was called the vertex. Anyways, yeah, that's what would happen to the graph. Right 1, up 2. So that means the vertex would be right 1, up 2. The vertex would be at 1, 2. Okay. All right. Now, I don't think we've done the other one. Y equals x cubed. This is new. Okay, so let's try plugging in those 5. If I plug in -2, what's -2 cubed?
-8.
-8. 2 times 2 times 2 is 8. -8. Just to throw you off here, what's -2 to the -3rd?
1 over -8.
Yeah, it's -1/8.
Okay.
Yeah, the negative can be anywhere, but yeah. Remember the negative exponent flips it upside down? Maybe not. That's why I'm reminding you. But okay. So what is -1 to the 3rd?
-1.
Negative times negative is negative. 0 to the 3rd. 1 to the 3rd.
1.
2 to the 3rd.
8.
Okay, let's see what this graph looks like. Okay, so we got 0, 0, -1, -1, 1, 1, 2, 8. Okay,
Can't use
8, 2, 1, 2, 3, 4, 5, 6, 7, 8. The other one's right down there. Kind of, graph's not quite tall enough. Okay, it really is supposed to get very flat right there and then start going up again. So instead of a parabola where it goes up on both sides, it actually on the negative side of the x, it goes down. This point in the middle they call the point of inflection. It's kind of the middle of the graph. So, wait, I forgot how to spell it. Second one was right. Okay, the point of inflection. Normally it's at 0, 0, but if we put some numbers in there, okay, this would move the point right 3 and up 4. Okay. All right, any questions on that? Most of this stuff will go pretty quick until we get to the graphing section. It's pretty fast though. All right, there's 6 graphs.
Yeah.
Are you ready? So I said it'll go quick, so that means you gotta need
No.
to be buckled up and ready to go.
Not ready yet, Mr. Jordan. Jordan, don't start yet, please.
Number 1.
Mr. Jordan, have you ever listened to a band called TV Girl? You should start in the front row.
Should I start in the front row? I feel like it's maybe.
It ended in the
Start
front
with
row.
the. You should start with the.
I know. I feel like it ended in the front row.
You started with front row
I
last.
think you should start with the
Yeah, but I don't think I made it all the way through.
We should definitely show you.
Yeah, we should show them.
Okay, I'll start with a volunteer.
Me, I got you, Mr. Jordan.
No.
Bro, Jay.
Okay, I would have called on you if you hadn't said that.
James, be quiet.
All right, Davin. Number 1. So it says describe the translations, which means describe how the graph would move from a normal y equals x squared. How would this graph move?
So you would basically go down, up 5.
Up 5. So notice the +5 is not in parentheses with the x. So it's not moving left or right, it's just out to the side. Should I put the thing up here on the board? I do want you guys to have these memorized by the time we get to the test.
I can't forget it.
Okay, what's the 1 do?
Left one,
Left 1,
up 2. What's the square?
up 2. The squared makes the shape, the parabola. Let's do 3 and 4. Alright, so this would be
Right.
right 3, down 4. This marker's kind of dying. Anyway, you get those in your head. Okay. Number 2.
What?
Let's go counter.
What in the one?
Oh,
No.
didn't he say it? I forgot. Oh, who did this? Davin, what'd you say?
Up 5.
Up 5. Yeah.
Is that all? I thought
I told you guys it was gonna go quick. Number 3. Alright, I guess we'll go ahead and go James here. 3. James, what's that graph gonna do? Left 7. Alright. Number 5. Abby, what do you think that will do? That is number 4, which is correct, but how about number 5? Up 6, but what about the 5? Yes. So we gotta write them both. So right 5, up 6.
What if it has like a to the third?
Okay, that would change its shape. It would look more like 34, but it doesn't change how it moves. Like where the middle of the graph goes. Okay, I lost my place. 7. Oh, the letters. Atticus, any guesses on 7? So on Abby, look at number 5, the one Abby's just did. It was -5, and she said right 5. Plus 6 was up 6. So if that's true, what should we put for 7? So instead of -5, it says -h. Okay, which direction is it moving and how far is it moving? That's what we're talking about. So on number 5, the x minus 5 made it move right 5. So on number 7, the x minus h is going to make it move right. How far? Well, we don't know exactly, so we're just going to put h. Okay, h is some number that we don't know right now. Okay, and what's the plus k going to do? Up k. Okay, number 9 is very similar, but they're asking it in a slightly different way. It says, state the coordinates of the vertex or point of inflection of each function. Gosh. So it's going to be pretty similar. Let's answer it. Number 9, how would that graph move? Right 3 and up 1. Okay, so the vertex of the parabola is normally at 0, 0. But if we move right 3 and up 1, where is it going to be? 3, 1. So instead of saying right 3 up 1, we're kind of saying it in ordered pair form, like coordinates form. So we're just going to say 3, 1. Because the point 3, 1 is right 3 and up 1.
Is it wrong if you write it right 3 up 1?
Yes. They're asking for the coordinates of the vertex or the point of inflection. So in that case, where would number 11 be? Plus 8 would make it move left 8. So if it's left 8, what are we going to put?
-8.
-8. It's like -8 on the x-axis. And
6.
plus 6 means up 6, so that's positive 6. 13. Alright, this one just says plus 19, so how's that gonna move? Plus 19.
0.19.
Right, it's gonna move up 19, so what point is up 19? 0.19. Now, did you guys notice that one said x cubed plus 19? So what that means is the graph is gonna be up 19, but the shape would just be the squiggly thing. Changes the shape, but not where the middle of the graph is. Okay, number 15. What is the minus 7 going to do? X minus 7.
Right, so
Right 7. So what point is right 7 on the graph? Way over here, be called what? If you move right,
7,
0.7.
no,
7,
7, 0. The first number is the x coordinate, so you have to go right 7 and 0 up, so it's 7, 0. Where are we? 17. Okay, the letters again.
It's the same thing.
So the minus h, how's that going to move the graph?
just H. Just be H.
Yeah, it moves it right h, so that is a positive h, yes. And then it says minus k, how's that going to move the graph?
Left, so, I mean, yep, no, right, down.
Down.
So it'd be negative K.
Right, since it's going down k, that would be a negative value, so it's going to go from minus k makes it go down k. Okay, number 19 is the graphing part. There's a specific way I'd want us to graph these though. Hold on. Let me go over here. Okay, the first part, it says state the coordinates of the vertex or point of inflection. And then it says graph it after that. Ooh. Okay, we're going to make a little table. But we're going to start the table. Where is the vertex for number 19 going to be? What's the plus 3 going to do to the graph? Move it up 3. So what point is up 3? 0, 3. So I'm going to put 0, 3 in the middle. Okay, for my other 4 points, I'm going to use x coordinates that are close to my vertex. So I'm going to use what's close to 0, negative 1, negative 2, positive 1, positive 2. That should center our graph around the picture. Well, even before we draw this graph, the plus 3 is up 3, right? So we should expect the graph to be up 3. And parabolas go up like that normally, right? Okay, so I need to find my other points. Negative 2 squared plus 3 is what? Negative 2 squared is 4 plus 3 is 7. So our graph needs to go up at least to 7. Negative 1 squared is 1.
4.
Plus 3 is 4. 1 squared is 1, plus 3 is 4. 2 squared is 4, plus 3 is 7. If we do it right, there should be some symmetry here. 7, 4, 3, 4, 7. So 0, 3, 1, 4, 2, 7, 5, 6, 7. Whoa. Okay, 21. Something is very different about 21. It says cubed instead of squared. So that should change our picture. Okay. So where is the point of inflection going to be for this one? What's this plus 3 going to do to the graph? Left 3. So what point is left 3?
21 is x plus 2. X
Okay, so left 2. What point is left 2? -2, 0. Okay, so I'm going to choose x values that are close to this point. This is like the middle of my graph, -2, 0. So what x values are close to -2? -3, -4, and on this side, -1 and 0. This should help me if I'm zooming in on the middle, so it'll give me a better picture. -2, 0 is the middle. If I plug in -3, -3 plus 2 is -1. -1 cubed is -1. -4 plus 2 is -2. -2 to the third is -8. -1 plus 2 is 1. 1 cubed is 1. 0 plus 2 is 2. Cubed is 8. Alright, so this one's kind of tall. It's going from -8 to 8. I'm not even sure I can fit this on the graph. Let's zoom out so I can make sure it fits. And I don't know if you guys noticed, it's a little bit off to the left. -2, 0 is the center. -3, -1. Very steep. It's supposed to, these are all supposed to kind of look like number 34. They did a picture of it. Make the table and graph it. Alright, 23, x minus 4 squared plus 1. Okay, so this is an x squared again, so it means it should be a parabola again. So it should have a vertex instead of a point of inflection. So where should the vertex be? Yeah, right 4, +4, +1. So I'm going to put that in the middle, 4, 1. Then I'm going to choose, so that means the vertex is going to be, parabola's off to the right. I'm going to choose x values close to the vertex. Plug those in. When you go to your graph, you might make a, should be kind of over here in the first quadrant. Everything's going to be happening in the first quadrant. Probably doesn't have to be that big, but. All right, if I plug in a 3, 3 minus 4 is -1, squared is +1, +1, 2. 2 minus 4 is negative 2. Negative 2 squared is 4. 4 plus 1 is 5. You can kind of cheat on these with your graphs because 4, 1, 3, 2, 2, 5. Okay, that's what I got so far. You guys know where the other 2 points are going to be? Right here, because this is the vertex, right? This is the middle of the graph. So if there's a point right there, there should be a point right there. If there's a point right there, there should be a point right here. They're symmetrical. Parabolas are symmetrical. So I should have a point at 5, 2, and 6, 5. Alright. Okay, that's the slow part, then it speeds back up again after this. Okay, 25. So this time they're telling us how the graph's moving, and we're supposed to write the function ourselves. I'm going to use function notation. I want you guys to go ahead and practice it too so you get used to it. So instead of saying like y equals, I'm going to say f of x equals, like number 9. Alright, so we're supposed to make the graph move 10 units to the right. So how would we make it move 10 to the right?
Minus 10.
X minus 10 in parentheses, right? Kind of like this right here. X minus 10 in parentheses. And then don't forget to put a little square on it. These are all going to be x squared according to the directions. A little square on it. Okay, number 27, we have to make it go 3 to the left and 12 down. So how do I make it go 3 to the left?
Parentheses x plus 3.
X plus 3 in parentheses,
Minus 12.
and then 12 down is minus 12. Okay, 2 to the right and 1 up. 2 to the right,
Minus 2.
minus 2, and 1 up.
Plus 1.
Okay, 31 is the same thing except for there's using the picture instead of telling us what it's doing. So on 31, it's a parabola that's moved. How is that parabola moved on 31? It's moved up 2. If you look at the vertex, it's at 0, 2. It's up 2. So how do I make a graph that moves the parabola up 2?
X equals x squared plus 2.
Right. The plus 2 should be not in parentheses, but off to the side. That would move it up 2. Okay, and 33. 33, where is that vertex?
Minus 2.
right 2, down 2. So, how do I make the graph move right 2?
Minus 2,
X minus 2 squared, how do I make it move down 2?
minus 2.
Minus 2 out there. So on 34, you're supposed to, you look at the point of inflection to figure out where the graph has moved. So where has that graph moved on 34? Where's that point where it's like normally in the middle?
2.
Left 1 up 2. So your answers are going to look a lot like this, but instead of an x squared, you're going to have to put an a little 3, x cubed on your parentheses. But the point of inflection is left 1 up 2, so you have to make it move left 1 up 2.